Good afternoon. Today I will be demonstrating how to solve CO2 as a Lewis dot structure. Our first step is to determine the group that the element is in. So for example, carbon is in group 4, so it has 4 valence electrons, and oxygen is in group 6, so that means it has 6 valence electrons. And these groups are on the periodic table. So like I said before, carbon has 4 valence electrons and oxygen has 6 valence electrons. Next to oxygen, there is a 2, so that means we are given 2 oxygens. So because there's no number next to carbon, we are going to multiply carbon 4 by 1, giving us 4. And then because oxygen has 2 next to it, we are going to multiply it 6 by 2, and that'll give us 12. So now that we have both 4 and 12, we're going to add that, and that'll give us a total of 16 valence electrons. So now we can start to place them into their pairs and their chemical bonds. So we can start off by going 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Keep in mind that we have to have a full octet, which is a total of 8 valence electrons. So on this side, we have an octet with 8 valence electrons, and on this side we also have an octet, but carbon does not have one. So what we can do to make sure that carbon has an octet is we can share our pairs. Erase these and add the pairs right here, and do the same over here. There is a full octet for oxygen and carbon. And then here it is again. So now your Lewis dot structure should look something like this. And one of our very last steps is to make sure that we have our chemical bonds. So this means that the VSEPR shape will be formed. So in order to do this, all we have to do is just connect these, and these themselves will be chemical bonds. So now you have your double bonds and your Lewis dot structure and your VSEPR shape. And this is basically how you solve it.